This problem is a quantitative problem. So we have to actually either use a solver or use math to determine what's going on. And it's a little trickier than some of the other problems that we've done because we're not given the velocity, but we can find it. And typically on, for example, an AP exam, you would need to justify your calculation of the speed of cart one before the collision. This is the information that we're going to use to find the speed of cart one. For our upcoming test, it's enough to just say, for example, doesn't appear to be any acceleration. Okay, and there doesn't appear to be any acceleration. So that's enough. And with that information, it's pretty easy to recognize that with no acceleration, that the velocity is going to be displacement divided by time. That's the average velocity, but that's the same as the initial velocity and the final velocity, because there's no change in velocity, no acceleration. So that's going to be goes 40 centimeters in 2 seconds. And we can use centimeters in momentum, it's fine. But because we're sort of used to using meters, let's do that. So that's 40 centimeters is 0.4 meters. So 0.4 divided by 2 is 0.2 meters per second. That's our initial velocity of cart one. With that information, we can now put together a, a, a drawing that will help us find the final velocity of cart two. And again, you could use the solver for this, or you can use the math is not super complicated. So what we're looking at is a collision that looks like this. We have no velocity of the 750 gram object before the collision. After the collision, they stick together. So we have 500 grams and 750 grams moving at one velocity. This is a perfectly inelastic collision. So in this case, what we should see is that the initial velocity of the 500 gram cart plus the initial velocity of the 750 gram cart should equal the combined masses times this final velocity after the collision. And this is the variable that we're looking for. So our final velocity is going to be equal to m1v1 plus m2v2 divided by the combined mass. Since all our masses are in grams, we could just use grams. The units will cancel out. But if you choose to use kilograms, which I would recommend just because so many of our other units require us to use kilograms, then this is 0.5 kilograms, this is 0.75 kilograms, and this would be 1.25 kilograms. So our final velocity, this is 0 because it's not moving. The larger cart's not moving before the collision. So this is going to be 0.5 times 0.2 divided by 1.25.